What is energy? Energy is a fundamental concept in physics and refers to the ability of a system to do work. It can exist in various forms, such as kinetic energy, which is the energy of motion, potential energy, which is the energy stored in an object due to its position or configuration, thermal energy, which is the energy associated with the motion of particles in a substance, and many other forms. Energy cannot be created or destroyed, it can only be transformed from one form to another. The law of conservation of energy states that the total energy in a closed system remains constant over time, meaning that the amount of energy at the beginning of a process must equal the amount of energy at the end of the process. Energy plays a crucial role in many aspects of our lives, from powering our homes and transportation to driving technological advancements and shaping our understanding of the universe. As I mentioned earlier, energy is the ability of a system to do work, where work is defined as the transfer of energy that results in a change in the motion or configuration of an object. When we say that an object has energy, we mean that it has the ability to do work, such as moving another object, lifting a weight, or heating something up. Energy exists in various forms, and each form has its own unique properties and characteristics. For example, kinetic energy. This is the energy of motion, and it is related to an object's mass and velocity. The faster an object is moving, the more kinetic energy it has. For example, a baseball thrown at a high speed has more kinetic energy than a baseball thrown at a lower speed. Potential energy. This is the energy stored in an object due to its position or configuration. The most common form of potential energy is gravitational potential energy, which is the energy an object has due to its position above the ground. For example, a rock at the top of a hill has more potential energy than the same rock at the bottom of the hill. Thermal energy. This is the energy associated with the motion of particles in a substance. The faster the particles are moving, the more thermal energy the substance has. For example, a pot of boiling water has more thermal energy than a pot of cold water. Other forms of energy include chemical energy, electrical energy, nuclear energy, and electromagnetic energy. It's important to note that energy cannot be created or destroyed. It can only be transformed from one form to another. This is known as the law of conservation of energy. This law states that the total energy in a closed system remains constant over time, meaning that the amount of energy at the beginning of a process must equal the amount of energy at the end of the process. For example, when a light bulb is turned on, electrical energy is converted into light and heat energy. The total amount of energy before and after the conversion is the same, but it has simply been transformed from one form to another. Energy plays a critical role in many aspects of our lives, from powering our homes and transportation to driving technological advancements and shaping our understanding of the universe. Understanding the properties and characteristics of energy is essential for understanding the world around us and for developing new technologies that can harness its power. One important aspect of energy to consider is its units of measurement. The standard unit of energy in the International System of Units, SI, is the joule, J. 1 joule is defined as the amount of energy needed to perform 1 joule of work, which is equivalent to exerting a force of 1 Newton over a distance of 1 meter. However, other units of energy, such as the calorie, are still commonly used in certain contexts. 1 calorie is the amount of energy needed to raise the temperature of 1 gram of water by 1 degree Celsius. Another important concept related to energy is power, which is the rate at which energy is transferred or transformed. Power is defined as the amount of energy transferred or transformed per unit of time, and it is typically measured in watts, W. 1 watt is equal to 1 joule per second. For example, a 100-watt light bulb transfers 100 joules of energy every second. Energy can also be classified as either renewable or non-renewable. Renewable energy sources are those that can be replenished naturally, such as solar, wind, hydro, and geothermal energy. Non-renewable energy sources, on the other hand, are those that are finite and cannot be replenished once they are used up, such as fossil fuels like coal, oil, and natural gas. In addition to its many forms and units of measurement, energy is also important in various scientific fields, including physics, chemistry, and biology. Understanding energy is essential for explaining natural phenomena, such as the movement of objects, the behavior of particles, and the processes that occur within living organisms. Furthermore, energy plays a critical role in many aspects of our daily lives, from powering our homes and vehicles to driving technological advancements and shaping our understanding of the universe.